So as I mentioned, this is going to be over advanced geomodeling. The last week we did one on or comparing the differences between X section and geomodeling cross sections. And before that, a little while ago, we did one on just a geomodeling 101, kind of how to get started in geomodeling. So this one's going to be kind of taking that a step further and working with the geomodeling engine and some of the tools that go into that. So we'll be looking at those as we go through here. So the geomodeling engine is built directly into the GVerse geomodeling application, and it is the engine that's going to be used to build the contours as well as display those contours into the 3D environment. It has some built-in tools for modeling a particular region. Those tools are going to be these ones listed here: your fault offsetting, your conformance, unconformity trimming, fault networks, and unconformity networks. All 5 of those are built directly into the module, and you may see them in your map view and your cross-section view as little icons along the top that you can engage and turn off as needed. And then we'll also be looking at making some contour maps based on zone thicknesses or interval data. So we'll go ahead and look at the couple of tools here. First one's the fault offsetting. Fault influence and throw is based on a fault plane that you build either through map view or cross-section view. Your fault offset is automatically applied given the dimensions of the plane, as well as kind of the geological setting and the geological area you're working in. Again, when you work inside of X section, you're going through and kind of manually setting what the vertical offset is going to be, whether it be directly in the cross section or as it's imported, that information's in there. Here, it's automatically reading whatever's in the region and building that fault information for you. You're able to view some fault gapping information and missing section information directly there in the cross-section view. So you can gap the fault, see where those missing tops are in that gapped section, and just kind of get an idea of what the surfaces are doing once it's faulted. Your fault plane, fault cuts, and vertical separation maps are viewable directly in map views. You can kind of get a contoured region of what that information looks like directly on the map. And see, again, where your fault cuts are propagating throughout your structural plane. Your conformance engine is based on the stratigraphic order of your project. In many cases, whenever you work inside of a project, you have your strat column manager. That's the list of all the information that you want to work with. And in most cases, it doesn't necessarily have to be in stratigraphic order. That's all going to be based on where you're picking your tops and everything else like that. However, when working in geomodeling, it must be in the correct stratigraphic order. If formations are out of order, then either your unconformity trimming, your conformance, or any of your thickness mapping won't be read correctly. If one top is above another, but you're trying to build it based on where it's supposed to be below a surface, you'll need to rearrange that order in your strat column. So strat order is very important here. One surface in this case can influence another. As you're picking a shallower surface, it can influence a deeper surface that doesn't have as good well control. So that's primarily where its use comes in here. Areas of poor well control and your deeper surfaces with few picks. So you can get an idea of what that trended area will look like based on another surface that's well picked. Your unconformity trimming. In your strat column manager, you can set a surface to be an unconformity. When that surface is an unconformity, it will truncate up against that surface and will no longer continue beyond it. So you get an idea of where a particular surface is being truncated and where that missing section is, again, there in the map. So again, formation order is very important for this case. It will determine on which side of the unconformity the surface will be truncated, depending on the order that it's in your strat column. Much like fault gapping, we can view unconformity gaps. Where there's missing section between these two tops, you're able to view those surfaces as they come into play there, and get an idea again of where that information is coming from. And in map view, you can show that missing section within the contours, and you'll see little cutout areas of where there is no contours being drawn based on that unconformity. Unconformity networks. If there are multiple unconformity surfaces, then you'll be able to see kind of which one's younger, truncated across other surfaces that are in there. Where they cross, one will stop and the other one will continue. And it's useful for fluvial and channel picking and display, and we'll kind of see an example of that as we go through here. And again, formation order, very important in Strat Column Manager. So that's going to be kind of an ongoing theme here. This module very much depends on having surfaces in the correct stratigraphic order. And then the last one, fault networks. Similar to unconformity networks, crossing faults will truncate through there, and you'll be able to see kind of where one fault stops and gets truncated by a new one coming through. And we'll be able to see some of that here as we go through as well. And then the last section we want to look at here is your contoured data. So in addition to just being able to see a contoured surface based on a particular formation top, whether it be coming from well-based data, isomap grids, or seismic horizon data, we can also build contoured maps based on zone thicknesses. So zone thicknesses will be based on the formation tops or whatever your surfaces are being sourced to directly there in the geosurface model properties. They're similar to isocore maps made in GeoAtlas. You pick a top and then another formation down, and it just builds a thickness map based on that information. But in this one, you can include interval data picked in the cross-section view. So then if you have picked out any pay or porosity thickness information, you're able to map that directly in here through these zone thickness maps based on either your true vertical thickness or true stratigraphic thickness. There's a couple options in there. And yeah, contoured surface there is going to be based on your vertical separation. Oh, I'm sorry. With maps that are showing your vertical separation maps, it's going to show you a contoured surface, determining where you have some highly vaulted areas in the map. And so we'll take a look at one of those as well. So with that, let's go ahead and take a look and see how some of the stuff works. So I'm going to switch over here to geomodeling. I've got a fairly small project area I'm working with. And we're going to start by looking at the unconformity trimming, kind of how that's treated directly here inside of the interpretation. So my geosurface model properties, I have a surface here that's labeled as an unconformity. And that surface type, again, is going to be set in your Strat Column Manager. If you do need to go and set that, it'll be in your Strat Column Manager, there will be a column for type. And in that drop-down box, you have a couple of options: conformable, unconformity, nonconformity, and disconformity. When it's set to unconformity, your surface will show as a wavy line over here, indicating that it is set correctly. So any surfaces that need to be set as unconformities, set them here in Strat Column using that type column. Once it's applied, then again, you'll see it appear there in your geosurface model properties as an unconformity. And then if there are multiple unconformities, then you can set up your network, and so that's where the networks tab is set up here. Multiple unconformities are listed here. Whichever one needs to be networked to another one, or where they're going to be truncating, you can click and drag and drop one unconformity on top of another one from this list. I only have the one unconformity in this area right now. The same is going to go for fault networks. You'll be able to see those listed in there. I have another interpretation we'll look at for that. So right now we're just going to focus on the unconformity. Along the top toolbar here, these are the geomodeling tools I was talking about. So these are fault offsetting, conformance tool, unconformity trimming, fault networks, and unconformity networks. All of those could be toggled on at the same time or just one at a time, simply picking and choosing which ones you want to model, and then update the model to turn them on. So let's go ahead and we're going to look at this in a cross-section view. Got a cross-section here in a structural view. The surface that is acting as my unconformity is this red surface right here. That is my MNLS surface. And I'm going to go ahead and flatten on that. Let me full zoom there. So there is the unconformity. You'll see some surfaces will cross over there. I'll see some predicted tops through here, indicating where I don't have actual well picks, but based on the grid, that's where we think the picks are supposed to be. And if I turn on my unconformity trimming and then update the model, I'll be able to see those surfaces will truncate. Oh, sorry, I need to change my draw mode. There we go. Surfaces will go and truncate against the unconformity and will not continue on any further. So, as I said, as the surfaces cross, I'm taking out the sections that are going to be missing. If I go back into map view, I'll be able to see on the map where those unconformities are coming through. So there's the missing section areas where the surface is truncating against the unconformity. And if I want to see the unconformity lines, then I can turn those on over here as well. Since there's an elusive surface, and I need to check this one on here. The MLBS surface is the one I'm displaying, and you can see the unconformity cut drawn around the contours there. So you can kind of get an idea of where that's drawn in there, and you can do that for each surface in there. So some of them not cut as much, others have more missing sections on the map there. So like you can see fault cuts, you're able to see unconformity cuts as well, and then you can also view that directly in the 3D view. In the 3D view, you will also be able to see unconformity gaps on your map. Now, one thing that you can't do with these unconformity gaps is, as you're drawing this here in the geomodeling section, as you're able to take a geomodeled surface and then bring that over into GeoAtlas as a contoured map. Unconformity gapped areas will not be able to be brought over. GeoAtlas doesn't have the same engine as the geomodeling, so it won't be able to display that missing section. But you can still bring over the full surface with it. A fault offsets and that information will be brought over, but not the unconformities. So we'll switch back over to a cross-section view here. And I mentioned before, you can view the unconformity gap and kind of get an idea of where some of that missing section is. I'm going to put this back into structural view. And then I'm going to go ahead and set on my unconformity gapping. So in the unconformity gapping, I'll be able to see kind of where some of that missing section is coming through. And I'll see in the dotted line here, those are my MLBS tops that are missing within that section, showing through in the unconformity area. And I'll be able to see other tops that are missing in there as well. There's my MLCM surface here at the bottom of that section, and then it's picked up the rest of the way over here. So anywhere that surface truncates inside of the unconformity, I'll be able to see that missing section in that gapped area. All right, so that's my my unconformity there. Let's switch over to take a look at some of the fault offsetting that we can do in there. So let me switch over to a different interpretation here real quick. And that is my fault interpretation. So in this interpretation, I'm going to have a couple of faults in here, and then we'll also take a look at some of the other kind of contoured maps and contoured surfaces that you can build. The fault offsetting, like I said, is going to be based automatically on some of my my geological section in the area. And I'll go and open up the cross section here. So I have two faults in this this cross section. Fault B, indicated here by the kind of the bright blue line cutting through the wells here, and then fault A, kind of going through here and crossing along that that fault, as well as a couple of the wells there as well. These are very shallow faults in this area. And like we did before with the unconformity settings, we have the engine along the top here with the yellow icons. I'm going to turn on my fault offsetting and my fault network, and then go ahead and update the model. And I'll go through and refresh both my cross-section, my map, and my 3D view all at once. As mentioned before in some previous webinars, the geomodeling engine is a live model. So as you're working in here, one change you make to one view is going to affect the change in other views. So let's kind of zoom in here and take a look at it. There's my my fault there crossing over the fault B here, and it will be truncated against that surface. If we look at the way the network's set up here, fault A is networked under the fault B. So that is where it will cross and be truncated at that position. So networks are set up much the same way you set up surface constraints. Click and drag and drop, and it will set up that that network. Very similar, handled the exact same way. With that that network going on there, I can also view much the same way I view the unconformity gapping. I can view the fault gapping. So right here in the cross section, right click in here and go to gapping, base it on the fault. And anywhere that I can see and you got a missing section, I'll be able to view that directly there between those surfaces, same way that you do with your unconformity gaps. And yeah, you can view this only whenever your cross section is in the true space mode. When it's in straight line mode, or you have surface projection turned off, then the fault gapping will not, or the fault gapping and unconformity gapping will not be available. So if you're trying to use it and you see that it's not doing anything, check your draw mode and make sure that it is set correctly. Go over to the map view and kind of just get an idea of what some of these look like. So as I mentioned before, you can view your fault plane. That's the whole fault plane for that particular surface, and then you can also view the fault intersections. So there's the black line indicating where the fault B intersection is occurring. Fault B plane, you can see the fault plane for that particular fault that's been picked, and the same fault intersection. They're intersected at the same point, so it looks much the same way as the other one did. And if you want to view the fault cuts for each individual surface, those will be listed under correlation and unconformity tree diagram there. So you can see a number of different fault planes and fault cuts being displayed there for all these surfaces and kind of what it's cutting across and truncating. And again, same for fault A. I mentioned before that you can view a map based on your fault information, kind of getting an idea of where some highly faulted areas are, and that is your fault vertical separation map. So here's a contoured map for fault B, and then following along where that fault intersection occurs, I can see that there's some highly faulted areas in there. So contour map based on that information displayed there directly on the map. Actually, I don't have one for fault A. So yeah, I can view that contour of that vertical separation, figure out what my highly faulted areas are, and they should correlate along with where I have that fault cut or anything else going on directly there in the map view. So while we're in here, I'm also going to take a look at some of the zone maps. In the cross section that I've got over here, I've picked out a couple areas of interval data. Here in yellow, I've highlighted some pay zones across a couple of the wells. So you can see here, based on kind of where I have my oil fill directly in the Prism template, I've just picked out some pay zone areas from that. Just kind of quick and dirty. Some of it's not going to line up exactly, and just kind of eyeballed that in a couple of wells and have that picked so I can use that data now. As an interval, picked directly in the cross section there to build out these thickness maps. So I'll go back over here to map view, and I'll see over here on the left, listed under zone maps, an option for the Minoleusa thickness map and an option for the pay zone map. So let's kind of see how those are created. In your GeoSurface model properties, on the last tab in here, you have a zone tab, and this zone tab is where you can build out zone maps. So you'll give it a name. I named this one the Minoleusa thickness map, and you choose a top and then a base, and then whether it's going to be a gross thickness or net thickness. And if there's any interval data applied to it, you can choose that from the drop-down menu here. If you're going to be including interval data, you must change the attribute from gross to net, and then from there you can choose the interval drop-down. When it's in gross, I don't see any interval data drop down for that. And then, like I said, for depth, whether you want it to be in true vertical or true stratigraphic thickness. So that surface is going to be read from your Minoleusa top as it is stored in well base and how that surface is being displayed. And the MLBS surface is my base. So again, those tops as they appear in well base. That's how I have these surfaces sourced. Remember, you can always check your surfaces tab here and just check to see what the data source is. Data points from well base, an isomap grid, or geosurface, or a horizon picked in GVerse geophysics. So I got that thickness map built here. Underneath that is my pay zone map going from the OPCH surface down to the MLCS. And you can pick and choose those surfaces as they appear in your GeoSurface model properties. So whichever surfaces you have available in there, you'll see in your drop-down menu here. And then attribute is set to net, and the interval data is whatever intervals you've picked, you can include that here. So I picked pay, that's one that I have chosen. And if you need to add additional ones or any other zone surfaces, you simply click the plus sign over here and create more layers for that over there. Any maps that you're not using anymore, hit the X button to remove them. So let's go ahead and take a look at some of those maps. Go ahead and turn off my my faults here. And scroll down under the attribute maps. There's my zone map. There is the Minnaloos thickness map. I'll see some missing section in there, given where the fault cuts are coming in through there from the various faults. Now, if I don't want to see that missing section or anything else in there, you can toggle off your fault network and fault offsetting to see the full surface. Same with the pay zone map. I'll throw that on the map there. Pay zone here was based on, was it the OPCH surface? So I can kind of see where some of that's missing area there on the map. But that pay zone map is again just based on wherever I have the pay zone data picked in my cross section. Then it'll contour and build the map based on all that information, and then go out to the extent of the project area, interpolating across the rest of that information. So much like any other layers, those can be brought out into to GeoAtlas and modeled more cleanly, or changing any data points or adding additional data points over there, or updating the map here in here as well. So yeah, those are kind of some of the various surfaces that you can build outside of the additional just modeling surfaces through your normal correlations and conformity maps based on that information in there. So very similar to what you can kind of do in GeoAtlas by building those thickness maps or building those pay zone maps, again, based on interval data in this case. All right. So there's one last thing I want to look at here, and that is going to be the unconformity networks that we were talking about before. The unconformity networks work a lot in the same way that the fault networks were working in. And that fault network is in cases where two faults are crossing over a certain area, or any number of faults are crossing over a certain area, they all truncate on one of those particular faults. However, with the unconformities, you can do a little bit something a little bit different. Get this out of the way. And with that, you can set up what we call these channels features, and the channel features will work in, a particular area where your surface is very shallow or doesn't have really good well control, but it's also acting as an unconformity surface. It will kind of bend itself up to a surface above it and create that channel feature. So kind of get an idea of what that looks like. Oh, wait, sorry, 1 second. Jump over to the AOI. So I got one set up here with a particular channel feature, a couple unconformities running across each other. And that channel feature is going to be set in your GeoSurface model properties, whether you want that unconformity to be treated as a channel or not. So we'll go ahead and take a look at that. Wait for this to open. Okay, I'm just going to move this out of the way. All right, so here on my map, got a couple of surfaces I'm going to look at. That's going to be my K8B and K8 surface here. The K8B is going to be acting as my unconformity surface. So I can come over here to the K8B. I'll see that that is an unconformity, and I have checked the box over here to make that a channel surface. So that means when I take it into the cross-section view and I turn on my unconformity networks, that surface will then kind of create that channel view. So I'll go ahead and open up that cross-section. It should be this one here. So in this this particular cross-section, here is my K8B surface. And then the K8 surface just above that. Now that K8 surface should be kind of being truncated by this particular K8B surface because that is my channel. And that channel should be closing off above the surface just above that. If I look at my conformance setup, the K8 surface is conformed to the K7, which is conformed to the K6. So some of that set up here, and I go to my networks, K8B underneath the K7 surface above it. The K7 in this case is the dark blue surface in between, just above the K8 and the K8B. So to kind of see what that'll look like, this will pinch off up into that K7 MFS maximum flooding surface, and you'll create that channel feature. So I'm going to toggle on Unconformity Network, update the model, and we'll see that those surface lines draw up and connect up to the K7 MFS, and then within that is my K8 surface within that channel. So it automatically will kind of read that information and create that channel feature. I'll go back to my map view, and I'll be able to see there is my my kind of channeled contour surface, and a little bit blossoming out outside of that as it extends a little bit further off here to the left for that particular surface. So I've created that that channel there. If I want to get an idea of what that looks like in the 3D view, I can come over here, and there is the let me turn off the fence diagram here real quick. There is the contoured channel, the K8B surface, and then inside of it is my K8 surface within that that particular channel. So any of those areas where you've got that that contour kind of bending up and creating that that feature, you can toggle that directly into your GeoSurface models, finding those unconformity surfaces and setting them to the channel feature. Now they have to be an unconformity surface type in order for that checkbox to be available. For normal formations, checkbox is grayed out, so I can't really apply it there. So make sure that those surfaces are set up as unconformities before going through there, and just making note of what your unconformity networks will be doing within within that particular model. All right. So we've gone through and talked about all those various models there. And like I said, you can toggle those on and off at will simply by updating the model as you go along. And you can toggle them off in either a bulk update. You can toggle several things on and off at the same time and update the model all at once, without having to, in the past older versions, having to click on one of those models, it taking a while to update, and then clicking on the next one to do the same thing. So now you can do all of that in one big refresh, as opposed to several smaller refreshes. All right, and so with that,